Hi, everyone. Thank you so much for joining me in this session that's all about getting our students to play with math. We're going to see how we can use manipulatives with middle and high school students so they feel like they are playing with math concepts and figuring things out. We want them to feel like it's fun, but we will know that they are making connections, seeing how things work together, and making sense of the math. Hi, I'm Rachel Edmonds, and I love coming up with activities and strategies that get students thinking. I love when we can get students to really understand math concepts deeply. I think that conceptual understanding is so important if they're going to be able to build and build as they move on in grade levels. Math manipulatives can play a really important role in helping them develop that understanding. They are not just for little kids or elementary students, even though they're very important for them, but they're also important for middle and high school students. I love using analogies, so I'm going to use a quick analogy for what I hope you will take away from this session. Okay, so look at this. This is a pumpkin muffin. I make these frequently in my household because they're really simple. I discovered this very simple recipe, and all you need is a box of spice cake mix and a can of pumpkin. Those two ingredients mixed together make this most wonderful pumpkin muffin. And it's so simple. You just bake it at 350, 30 minutes. Turns out perfect every time. I love these muffins. I could have them all the time. But I discovered something that makes these muffins even better, and it's chocolate chips. So I took what was a pretty good muffin and made it something amazing. Something that I think now, how did I ever eat these without chocolate chips? Okay, so that's how I hope you will see your math lessons after today. Maybe you had a really good recipe. You had the right ingredients for something that was a very solid math lesson. But manipulatives are going to be like the chocolate chips. Once you start using them, you'll think, how did I ever go without these? Why did I ever teach these math concepts without this hands-on approach? Because the manipulatives are going to make your lessons so much more deeper. They're going to make it more engaging for students, and I hope you'll see a lot of aha moments. Today, I have specifically chosen math manipulatives that you and your students can create yourselves, because I know we can't all just go buy a bunch of materials. Hopefully, these are something you can print and cut and create and use the next time you teach these concepts. Now, they're going to range from a lot of different topics in middle and high school, and I hope you see some you can use with the standards you teach, but I would encourage you to try them all out as we go. If you haven't had a chance yet, go ahead and print off the materials, and you might want to pause. We might move a little fast to get through everything today, but try them out. Try to figure out the different things we're working with and see if you make new connections as you think through how all these manipulatives work together. I hope I have included some that you have not seen before. I think as teachers, we don't often get the experience to see something through our students' eyes, through the eyes of a learner. So I hope you have some new experiences today, some new connections are made. Hopefully you'll get to try out some things that you haven't thought of before, because I think that helps us relate to students a lot more. When we get to experience maybe a little bit of struggle, maybe a little bit of, ooh, I'm not sure how this is going to work yet. I've got to figure it out. I think that helps us connect even better to what our students experience in our classrooms. We want them to have that little bit of struggle. Hopefully it's productive struggle. We want them to experience what it feels like to not exactly know the answer right away, but to have the tools and the manipulatives to play with it and figure it out. I hope that's what you will get out of some of the activities that we do today. I do want to point out one misconception that I often hear. A lot of times when I talk about using manipulatives, especially with middle and high schoolers, teachers tell me, okay, I'm going to try this with my struggling students. And yes, that is great. I think if we have students who are struggling, we need to try all kinds of different strategies to see what's going to work. But please do not save the manipulatives just for students who aren't getting it or who you think might struggle. Let everyone play with the manipulatives. What you will find is that these will help you differentiate. For students who really are struggling to get a concept, the manipulatives give them something tangible to start making sense of what's going on. For our advanced students, students who are really good at memorizing things or seem to catch on quickly, the manipulatives make them pause and make sense of what they're doing. They can't just memorize a formula or memorize the steps to get an answer. When we ask them to show us why it works, proving that process with something tangible. So the manipulatives are going to make students think deeper in many ways and maybe connect to other topics that we hadn't even planned. So please use these in your lessons with all your students and see the different thinking that goes on. You can also use them to help you differentiate by planning different questions. So all the students might be using the same materials, the same manipulatives, the same activity, but we can push certain students into deeper thinking if they're moving quickly with the questions we ask. And then if we have students who aren't quite getting it, we can use these tangible objects to help them piece it together. The reason I know that manipulatives are not just for struggling students, I've used manipulatives with teachers and they have aha moments. So that's why I say use them with everyone. It's going to make your lessons even stronger. All right, let's get going and start playing with math. Okay, be sure you have printed and cut out the manipulatives from the handout. I think you will get so much more out of this session if you play along with the prompts as we go. You don't have to use colorful paper here, any color will do. But we're going to start out with these unit tiles. And I think it's important to discuss what we are representing here. So with the unit tiles, each dimension is one unit and the square is one square unit. And we can use these for lots of different applications, but we're going to look at factors today. And you don't need to start the lesson with that. For students, it's just we're using unit tiles and we're going to do some exploration. So I want you to find 12 of these tiles and I want you to arrange them into a rectangle. You can pause if you need to. I will play along here on the screen and make a rectangle out of my 12 tiles. Okay, so here is the rectangle I created. Maybe yours looks something like this, or maybe it's another variety. But I hope if you tried it out, you kind of got a glimpse about what students might be thinking as they're working through this. They are thinking about how do I arrange this so that I use all 12 tiles. So they're thinking about factors without even realizing it. Now, some of them may just be playing with it till it works. Some of them may be thinking about math facts to make it work. You could see here we could arrange it in one long line of all 12 of our tiles. And then once students have their rectangle, what we want to do is ask them questions that really push their thinking even further. So we want to say things like looking at the rectangles in the class, what do they all have in common? Can you create any other rectangles using 12 tiles? What do you notice that's different about your classmates' rectangles? Then we want to, maybe prompt them with could a side length be just one unit if they hadn't made that one yet? How about four? How about five? How do you know whether or not these side lengths would work? Okay, now I want you to try to arrange 24 unit tiles into a rectangle. Pause here, and then I'll show you what I did. Here's the rectangle I created. It has 4 rows and 6 columns. So compare that to your rectangle. What do our rectangles have in common? What is different about them? What other dimensions would work? Okay, let's try one more. This time, gather 17 tiles and create a rectangle. Pause here. So maybe you knew what was going to happen here, but students might play with the tiles to try to figure out what's going to work. They might try different arrangements till eventually they see none of that's going to work. The only way to get this in a rectangle is to make one straight line of our 17 tiles. And now again, we have the opportunity to ask questions about what just happened. How was using 17 tiles different than using 12 or 24? Can you think of any other numbers that would also have that same result where we can only make a straight line to create a rectangle? And then after this exploration is a great time to really solidify vocabulary terms. We can talk about what a factor is. All those dimensions were factors. 12 has factors of 1, 2, 3, 4, 6, and 12 because those were dimensions that we found. That's going to make a lot more sense to students. We can also talk about prime and composite numbers based on this experiment. All right, next we're going to use algebra tiles. And the reason we're skipping along to algebra tiles is because they relate a lot to what we just did. Now, first, I think it's important that we define each of these, especially if students have never used them. This little square represents 1 unit. Each dimension is 1, and the entire square here is 1 square unit. Now, this bar here is x, and you'll notice the dimensions are 1 in one direction and an unknown amount in the other direction. If students tried to measure this side of the x tile, they could line up the units here, but it would not come out perfect. So we say that it's an unknown value. And since the dimensions are 1 by unknown, that means that we do not know the value of x. So it's kind of important here that the x tile does not match up perfectly to a certain number of our unit tiles. All right, and then this square here, the larger square is x squared. If we measure each dimension, its length and width are both x, which gives us x squared for its value. We're going to start off multiplying two binomials, and it's important that students realize that multiplication is connected to area. When we multiply two factors, the factors are the width and the length, and the area represents the product. So if we want to multiply x plus 2 times x plus 1, we're going to set it up with our dimensions along the top and the side here, and then when we fill in the area, that is going to be our solution. When we multiply these two binomials, the product is the area that we find inside. Pause here if you want to try it out. Okay, x times x gives us x squared here, and you can see how it matches the dimensions. And then we're going to multiply x times these two units. So here we have 2x. Then we're going to multiply x times this 1 unit down here, which gives us another x. And then we'll multiply 2 units by 1 unit, and that will give us 2 units here. Now here is our solution represented as the area, x squared plus 3x plus 2. Algebra tiles really make polynomials a tangible topic. Now, if this is the first time students have worked with multiplying with algebra tiles, I'd recommend doing several more problems, but we're going to move on and try to find factors. So with factors, we're doing the opposite. This time we're going to be given the area and we have to figure out the dimensions, similar to what we did with the rectangles earlier, but now we'll have x's involved. Okay, so let's factor. And I love factoring with algebra tiles because it just feels like it's a puzzle. It doesn't feel like we're trying to follow some steps or a formula or anything. We're just trying to work out a puzzle. So I want you to gather these tiles, x squared plus 5x plus 6. So you'll have your large x squared, and then you'll have 5 of the x's, and then you'll have 6 units. And all you need to do is arrange these into a rectangle. Pause here and try it out. Okay, hopefully you had a chance to play with these until you made your rectangle. So we might start by placing X tiles here. Again, students aren't supposed to just get this right off the bat, especially if this is the first time. It may not feel efficient, but that's okay. We don't need to stress for efficiency when we're starting out. The thinking is what is important. So then our factors are going to be the dimensions. On the top, I have X plus 3. And along this side, I have x plus 2. Now yours may be arranged in the other direction where you have x plus 2 along the top, and that's perfectly fine. All right, let's try one more. This time I want you to use algebra tiles to factor x squared plus 7x plus 6. Pause here. So again, we're expecting students to just play with the tiles until they get it to work. And once they do, we can ask questions like, how do the tiles represent the solution? What patterns do you notice in the original polynomial and in the factors? Could you arrange the tiles in any other way to find the factors? All right, if you have never used algebra tiles, I hope this gives you some inspiration to try it out next time you teach polynomials. Now let's move on to area of a circle. You're going to need the circles and the unit tiles. And what I want you to do is try to figure out how many square units it would take to fill up this small circle. You can look at the square unit and compare the dimensions to the circle, but I want you to give it your best guess. And I also want you to think about what is a number you know is too low and what's a number you know is too high. Take a minute and think about that. Okay, now I want you to take your square units and try to make them fit in this circle. So you can cut them, you can arrange them however you want, but I want you to try to get the closest estimate you can. Pause here and try it out. Okay, now let me warn you, I almost left this out of today's presentation because it's not the nice, neat, perfect math that we're used to. This gets messy, and I don't mean just because we're cutting up things, but because it doesn't seem like we're getting the perfect answer. It seems like we may not be doing this right. We might be struggling or confused or not sure if we should try something different. But there is value in that. There is value in trying to work out different methods, and students might see methods that their peers are trying and want to try those. And how often do we rush to get to a perfect formula and students don't even get the chance to really explore what the concept means? How many students have really ever thought about the area of a circle? A lot of times they learn that formula and they know how to get an answer, but have they really thought about what is even reasonable? So, this exploration gets them to think about, what do I even think is a reasonable answer here? And then can I come up with my own method? And as we work through it, we're going to make some connections and learn some things along the way. Not just about area of a circle, but so many other ideas too: how to communicate, how to work together, how to work through struggle, and figure out the math that goes along with it. Okay, so here's what a student might do. They might say, I think it's going to take about 3 tiles. So I'm going to cut the tiles up like this. And then my extra pieces, I'm going to keep cutting them, making them fit. I don't want to overlap anything, but I'm trying to fill up all of this space. So it may take cutting them into little pieces, and that is fine. And then once we get them all in here, if I were the student, I would say, okay, I think it's about 3 square units, but it still looks like I have a little bit of space left over. So maybe my answer is a little bit more than 3 square units. And here's where we might ask the students, what connection do you think the circle's area has with its radius? All right, next we're going to look at the large circle. So same thing, I want you to try to estimate how many square units would it take to fill up this large circle. First, we might want to ask for some guesses that are too low and some guesses that are too high. I think that practice takes the pressure off of getting the perfect answer. We're looking for an estimate. Even if students aren't sure if they're doing it right, most can give an answer that they think is too low and too high. All right, so I want you to try it out again and try to keep track of how many square units you use. Okay, so remember, this is not supposed to be easy. You might have made a mess of this. That's fine. You might have noticed the radius is 2 units, so that might get you thinking about a prediction. Right here are 14 tiles, and I'm pretty sure that's too many, but I'm going to start cutting these up and keep track of how many I use. So I'm cutting up little triangles, little bits and pieces here and there until I fill up this circle the best I can. And I think I used 12 tiles here, and I still have a little bit of space, but I don't think it's enough for one more. And now is the time to really push their thinking by asking, do you see any connections between the small and large circle? What do you think the radius might have to do with the area? This is where we can get them to reflect on that process. And here's a little hint: after this, after they've worked through it, you might have them now cut up a circle to try to fit in the shape of a rectangle. And it really does relate a lot to the formula for area of a circle. But again, this exploration is to get students thinking about what area is even about. Are they making sense of what they're doing, of their answers? Are their answers reasonable? We could challenge them with, try to create a circle whose area is close to 1 square unit. These kinds of prompts get students thinking, get them to really see how they can make sense of what is going on. Now let's work with unit cubes and volume. In your handout, you have the net of a cube, so if you will cut that out and tape it together to create a unit cube. Now our unit cube is related to our unit tiles here, our square tiles. Each dimension is one unit. The square is a 2D shape and it's a square unit. The cube is a 3D shape and it's a unit cube. That is how we measure volume. We measure it in cubic units. So it really helps if students can have a hands-on approach to dealing with volume so they get a feel for what a cubic unit actually is. Now you're going to take a piece of paper and I want you to create a container that can hold exactly 18 unit cubes. Pause here and try it out. Okay, I hope you made your container because I want you to have that experience of what students might be thinking when they create their container. Now, I made some dots and things trying to figure out how I wanted my sides and my base. I suspect that students doing this will probably not have the plan in mind right at the beginning, so they may cut out their sides and base all separate and then tape them together, and that's perfectly fine. But hopefully they will come up with some sort of rectangular prism and we can see if it will fit 18 cubic units. And if it doesn't, that's okay. We can discuss what went wrong or what we might change for next time. And then if you have lots of these unit cubes, we can actually test it out. But we want to ask questions to students like, how did you determine the size of your sides? If you look at other containers that classmates have created, what differences do you notice? What was challenging? How many different containers could you create? There's lots of questions that we can push them to think deeper and deeper. And this is getting them to really think about how volume works. They likely will get to a point where they're thinking about how many cubic units they want on their base, and then they take that and think about how tall they need their container to be. And that's what we want them thinking about when they're doing volume. We want them to think about the area of the base multiplied by the height. After this, we could change the prompt to hold 24 unit cubes or 50 unit cubes, or ask them to create a container that can hold the maximum unit cubes using that one sheet of paper. There's lots of ways we could make this more challenging or get them to think deeper, and then we can discuss what they did to come up with their containers as we talk about volume. Next, we're going to explore triangles. Now I want you to look at these two triangles, ABC and XYZ. And what do you notice about these two triangles? Maybe pretend you're a student, but make some observations. And then if we're in class, it'd be good to discuss those observations. And then we might give this informal definition of congruent. What if we tell students that if I can translate, rotate, or reflect these two triangles and make them match, then they are considered congruent? And then we could let students play with it to see, can I make these two triangles match? Well, we can. Now we have made the concept of congruent triangles very tangible. And now we can discuss, well, what do congruent triangles have in common? Their sides match, their angles match, and we can talk about how to write a congruency statement when we match up those corresponding sides and angles. So we could say triangle ABC is congruent to triangle ZYX. Okay, next we're going to do an exploration with side lengths. So you have 4 different little sticks here. I've colored mine, but each one gets longer and longer. And I want you to use the 3 longest lengths, and I want you to try to create a triangle. So pause here and make your triangle. Here's the triangle I have created. Now I want you to compare it to the one you created. And if we're in a classroom, we'll ask students to compare it to others around them. What do they notice? Can they find 2 triangles that are congruent? Do you think your triangle is congruent to mine? How do you know? And we could think back to the experiment we just did where we had the tangible triangles that we moved around. We can still think about that idea. Could I take your triangle and either translate, rotate, or reflect it to create my triangle? Yes. Students will see that no matter how we rearrange these sides, we are still going to have the same 3 side lengths, and it will still create the same 3 angles, And no matter how we do this, we're going to end up with a triangle that is congruent to the one we already created. There will always be a way to either translate, reflect, or rotate and get that original triangle. And it's really powerful when students can see lots of different varieties of this triangle by looking around the room and then see that they're all congruent. Okay, next I want you to find the smallest length, the next smallest, and then the longest. And I want you to try to make a triangle. Pause here and try it out. Okay, what did you notice when you tried it? Can you make any generalizations or rules about the lengths of sides of a triangle? Maybe you saw that you couldn't make a triangle. And I think it's really good if students get to try it out and see for themselves what requirements do we have for sides. And then you'll start to get them to come up with rules on their own. Because they'll see, okay, these are too short, they can't reach. So the two sides of the triangle, they can't be shorter than the third side. And we're getting them to discover the triangle inequality theorem. Do you know what teachers say is one of the hardest topics to teach high school math students? It's proofs. But why are proofs so difficult? Why do we go through this long process in geometry to prove something and students find it so difficult to write these proofs? Do you know one reason? It's because they lack intuition. A lot of students are writing these proofs, but they're not even sure of what they're proving. They're not even sure they believe what they're trying to prove. If we don't give students that time to play with math, to have time to work with manipulatives, to see the different connections, if they don't have that time, they don't develop that intuition about geometric figures or about algebra concepts, as we saw in some of these activities. The more hands-on time they get, the more time to explore and figure things out, that gives them more intuition about math concepts. We want them to internalize what we're trying to teach them. We don't want them to just memorize how to get an answer. They have to understand how they got there. I hope those activities have shown you some ways you can use manipulatives in your classroom. But let me show you one more thing. One of the key parts of using manipulatives is how we ask questions. Yes, we can have all the hands-on things in the world, but if we don't ask the right questions, we won't get the most use out of those activities. Let me show you an example. What if I had shown you these tiles and said, hey class, let me show you how I can arrange 12 tiles in these different ways. Okay, see, here are my factors, here, here, and here. Okay, you get it? Those are the factors of 12. Do you see how that is a lot less engaging and a lot less impactful than if we let students play with them themselves? When they get to explore it, they are making those connections. It's also reinforcing a lot of fluency, multiplication skills, all these other topics start getting tied in that we hadn't even planned, but it's strengthening all those skills. Just showing students what to do with manipulatives and not letting them do it, that is not going to take us nearly as far. Letting them explore and asking the right questions, that's what gets them thinking. Now, I know the number one question I usually get is, won't this take a lot more class time? And the answer is yes, it will. But it's really valuable use of class time. We can tell students and move quick and tell them, here's a formula, here are the steps, get the answer, let's go. But is that going to really be lasting understanding? I always say the things that we pick up on quickly, we often forget quickly. If we want students to have that deep learning that will be long lasting, we have to teach in a way that allows them to develop those long lasting connections in their brain. They need time to work on that, to build meaning, to see how it all works together. And that's not a quick process. If our lessons are focused on short-term gains, we will miss out on that long-term learning. We have to shift our focus to how do I teach students in a way that develops that long-lasting understanding that's going to serve them throughout the year and in future classes as well. Okay, let's jump back to our analogy, the chocolate chip pumpkin muffin. The chocolate chips, that's what we focused on today, that wow factor. Manipulatives can give you that wow factor in your lessons and make them so much more meaningful for your students. But there are two other ingredients here, okay? The spice cake mix, that's kind of like the curriculum or the activities that you find for your students to do, the lesson, the whatever you have planned that day. But the pumpkin, that's you. The teacher is the pumpkin, and I would call it the key ingredient. Because let's be honest, nobody wants a bag of spice mix and chocolate chips. That's not going to work. The pumpkin is what makes all the difference. It's what holds everything together. And what I mean in a math lesson, the way we interact with students, the way we question students, that's what truly matters. I encourage anyone to use manipulatives, but what's really important are the questions you ask with those manipulatives, the interactions you have with your students, pushing them to think even deeper about the math that they're playing with. The questions we ask are so important to developing that conceptual understanding. If you have trouble knowing what to ask or planning meaningful questions, I've got a free guide that I want to send you. It's going to help you think through why you're asking questions and give you examples of what you need to ask. So if you liked the activities we did today, I've got all of them ready to go for students along with this questioning guide. And let me send it to your email so you can be all set to start using these activities in your classroom. You can sign up for it here. I hope you have enjoyed this session. I hope you will take away these ideas, use them with your students, explore even more manipulatives, see how you can incorporate those into your lessons, give it that wow factor, ask really good questions while your students are thinking and exploring, and I hope this takes your lessons to the next level. Thank you for joining me.